Thank you for watching this project help video for Lesson 12. I will help you answer each question in the project by providing step-by-step instructions using example problems. A good strategy might be to pause the video after each example and then work the corresponding problem in your project. Question 1. The inequality for the number of students' projects graded this week is x minus 21 is greater than or equal to 41. Okay, so graph this inequality. So basically, this is what we call an inequality in one variable, right? There's only one variable, x, and we're asked to graph the inequality. All right, so first we need to isolate the x. So we need to have x is greater than or equal to some number, then we can go ahead and graph it. So in this case, we have the inequality x minus 21 is greater than or equal to 41. All right, so if I'm going to isolate x, on the left-hand side of this inequality, the x is with this minus 21. So we're going to do the opposite of subtracting 21, which is to add 21 to both sides. All right, so we're just isolating our x the same way we would if this were an equal sign using inverse operations. And in this case, we get that x is greater than or equal to 62. Okay, so now I'm asked to graph this inequality. So when we have a single variable, we can graph that on a single number line. All right, so suppose back here was the number 0 on our number line. Then up here, we might have our tick marks. And suppose right here was 60. And here's 61. Here's 62. So what we need to decide is if the circle that we're using should be opened or closed, and then what direction the arrow should go. All right, so what direction the inequality should go in is pretty easy. If you have left on the x on the left-hand side, the inequality is kind of like an arrow pointing in which direction it goes. And then we use a solid circle to indicate greater than or equal to or less than or equal to, if that number is included or not. And in this case, we are including 62 as part of the solution set. So we go to 62 on our number line, which is right here. It's going to be a solid circle going to the right. All right, so that indicates that the solution set is all numbers 62 or greater. The inequality for the number of discussions graded in all my courses this week is 75 minus x is less than 15. Let's graph this inequality. All right, so same steps as question 1. We need to isolate the x, and then once we have the x isolated on the left-hand side of our inequality, then we're going to go ahead and graph it on a number line. So in this case, if I want to isolate the x term, I need to get rid of this positive 75. So I need to subtract 75 from both sides of the inequality. Then I would get that negative x is less than 15 minus 75 is negative 60. And now we have one last step here. We don't see a number 1 here, but you can imply when we have no coefficient that it is a 1, in this case a negative 1. So in order to undo multiplying by negative 1, I need to divide both sides by negative 1. And then we get that x is greater than 60, positive. Remember, a negative times a negative is a positive. And whenever we multiply or divide both sides of an inequality by a negative, we have to flip the direction of the inequality symbol. All right, so now if I'm going to graph this, here's the number 0. Suppose here's 10, 20, 30, 40, 50, 60 on my number line. Now I'm going to go ahead and use an open circle because this graph here, this inequality says greater than, just strictly greater than 60, meaning we don't want to include 60 as part of our solution, just anything greater than 60. So we put an open circle at 60, and then of course we shade all to the right, or an arrow going to the right. Those are all the numbers greater than 60 on this number line. All right, so question 3. In addition to the constraint put on x from the previous problem, So what do they say here, the constraint put on x from the previous problem? Remember that in the previous problem we had that x is greater than 60. So that's the constraint they're talking about. Okay, so x is greater than 60. It is also known that 75 total items, including discussions and projects, were graded this week. All right, meaning that the number of projects graded cannot be more than 75. Well, clearly not, right? If there's a total of 75 items graded all together, then the number of projects graded cannot be more than 75. Right? Write the compound inequality to represent this situation. Okay, so we have two pieces of information. The first one I have listed here. All right, so from the previous problem, we get that x is greater than 60. And we were referring to discussions in the previous problem, so it's really saying the number of discussions graded were more than 60. Right, so I'm going to go ahead and write that. Now from this problem, we get that the total number of items graded, right, is less than or equal to 75. All right, so we know that the total number of items, right, in this case, is less than or equal to 75. We could use the same variable x here to represent, remember in this case, discussions, because uh, if the total items, if the discussions here are greater than 60, and then all together they have to be less than or equal to 75, right? Then we could actually figure out if the question asked us how many projects were graded. But it's not asking us that here. It's just asking us to write the compound inequality to represent the situation using x. All right, so in this case, x has to be greater than 60, and though it has to be less than or equal to 75 because there's a total of 75 graded items altogether. So one way we could do that is write the two inequalities separately like this, and then join them with the word and. All right, this is different than the word or, right? So and implies that both things have to happen and they happen at the same time. You know, the number of projects graded is greater than 60 and it's less than or equal to 75. We know that because there's a total of 75 items graded altogether. All right, so an or implies that one thing is true or the other is true, but they're both not true at the same time. And so, for example, you could say, I have um, greater than 5 books in my backpack, or I have less than 1 book in my bag, which means either you have 5 or greater, or you would have less than 1 or less, but they're both not true at the same time. So then the question asks you to kind of graph that. You know, we'll talk about graphing that next, but this is not the only way that we could write this inequality. All right, so when we have an inequality with the word and, we can also write it as a compound inequality in this way, kind of like a range. So think about writing this backwards. So I could flip this around and it would look like this. So this says x is greater than 60. Think of reading this backwards this way. It still says x greater than 60 if you read it backwards. And x is less than or equal to 75. So this is typically how we see an and written, as a range. It kind of implies that this x here is in between 60 and 75. So now when you have an or, right, the only way to represent a compound inequality that's an or is with the word or in between. But this problem clearly indicates an and. Both of these things are true, and they're true at the same time. It's not one or the other. All right, so now this problem says, let's go ahead and graph that from the previous problem, or explain how you would graph the inequality. So let's remind ourselves of the inequality. All right, so one thing we should know about all these inequalities that imply the word and, right? is that they're a range. So when we graph them on a number line, they're connected. It's some value, some low value, some high value, and they're connected with a line in between, meaning all the numbers in between them are also solutions. Then you just have to worry about if the circle should be opened or closed. All right, so if I'm going to graph this on a number line, I would go to where 60 is on the number line. And if I remember, I'm reading this backwards. Here's the other way to write this. X is greater than 60 and X is less than or equal to 75. So if I'm graphing X is greater than 60, it's like I come to 60 on the number line, and it's an open circle, right? Because we don't have the or equal to, we don't include it. And it would be all the numbers going to the right of this. And technically, if I'm graphing just this one separately, they would go forever and ever. Suppose here's the spot 75 on my number line. If I graph the second inequality here, I get that X is less than or equal to 75. So at 75, I'd have a closed circle. And the shading or the arrow would be pointing to the left, all the numbers less than that. Notice that these two separate inequalities overlap in between each other. All right, so then we'd cut off the tails at the end, and this is how I would graph this inequality, right? It'd be an open circle at 60, and then a closed circle at 75, and they'd be connected with a solid line indicating that all the numbers in between, greater than 60 or and less than or equal to 75, are part of the solution set.